Good morning. All right, so we are going to pick up with chapter 2 today. So we're going to start with 2.1 on functions. I will adjust the homework as needed. So I'm going to wait and see how far we get tomorrow, and then I'll kind of adjust that date because I know we're going to need more time to get through 2.4. Again, the plan is I'm going to cover certain examples, and then other examples I'm just going to rely on the videos. And you can see if you look in the course content section of Blackboard, in the chapter 2 folder, I have the slides that we're going to be covering, but I also have videos for every section there. And so basically what I'm going to say is, as we go through a section, I'm going to pick and choose the examples I want to work through. If there's any additional ones that you want to see worked out, then you can go to the videos because I've done all the examples in the videos, okay? Or at least the ones that I think are important for the homework I've covered, right? So I'm going to kind of not jump around, but pick and choose specific examples rather than covering every single example in the section. That way we can kind of make up some time as we go. And then if there's ever anything you're questioning, then you can always go back and watch those videos to actually see any other examples that you might want worked out, okay? Don't forget the test is due by midnight tonight. So if you have not already completed and submitted that, you have until 11:59 p.m. At that point, the links actually go away. You won't even be able to get into the test or submit it. So just make sure that you're planning accordingly for that, that you have time to actually take the test, get out of the browser, scan and upload by 11:59. Okay? Any questions, comments, concerns before we get started today? So I'm going to try to grade them over the weekend. So at this point, right, I'll start on Friday and probably work all the way through Sunday because I've got your class and two other classes both coming in tonight. So it just kind of depends on which class I start with as to when yours will actually get graded. But that's my goal, is to have all three of those classes done by the end of the weekend. Okay. Yep. Yeah, I don't like them lingering over my head either. So I try to get them back to you as quick as I can. Okay. Any other questions? All right. And the only other thing I will say, I posted this in the announcements a couple of weeks ago, but there is a Black History Month presentation today at noon. And so if you're interested, the link to the flyer is in the announcement section. And then within that, there's a link to a Collaborate session. So it's virtual, right? You can just drop in and hang out and listen. But I just wanted to remind everybody there is that presentation at noon today for Black History Month if you're interested. Okay. All right. So functions. So in general, a function is a rule that's going to assign to each element x in a set A exactly one element f of x in a set B. In other words, for every x, there's exactly one y value. Okay, that's what it means to be a function. Okay, so if we have, and we'll look at examples of things that are not functions, if you ever have an x that has multiple y values assigned to it, it is no longer a function. That's what it takes to be a function. All right, so now we have a function f defined by the formula f of x is equal to x squared plus 4. So the first thing they ask us to do is put into words how f acts on the input to produce the output. So all we're doing here is describing verbally, order of operations, what would we do to our x values as we plug them in. So in this function here, what would be the first thing you would do to that x value that you're substituting into the function? Square it, right? So according to order of operations, we would do that exponent first. And so we would square the x. Give me 1 second. There we go. Now my pen's not working. There we go. Square the x. Okay, and then after we square the x, what will be the next thing we would want to do? Add the 4. Good, right? So those are going to be our 2 steps for this function here, right? You would square the x value, and then you would add 4 to it. So that's all it's asking for, is in terms of expressing in words what that function's actually doing. There could be some like multiple choice questions in the homework where they ask you that, and so you just have to choose which one of them actually does things in the right order there. Okay. Now, second part of this one says we're going to evaluate f of 3, f of negative 2, and f of square root of 5. Right? So let's start with f of 3. So all we're going to do to find f of 3 now is we're going to substitute 3 everywhere we see an x in our function. So when I do that, it's going to give us 3 squared plus 4. Okay. And if you think back to the verbal description that we gave, the first step is we're going to square that x value. So what are we going to get when we square 3? Nine. Good. So 3 squared is 9. And then our second step is to add the 4. So if we add 9 plus 4, what do we get? 13. Good. So f of 3 is equal to 13 now. And feel free to use a calculator for these, right? I don't actually need to see every single step along the way. As long as you know to substitute that value for every x in your function, then you can just put it in the calculator and get the value. Right, let's look at f of negative 2 next. Now, when I do this, I'm going to keep my negative 2 in parentheses because I want to make sure I'm squaring the entire negative 2. So what is negative 2 squared going to give us? Positive 4. Good. So we're going to end up with 4 plus 4. And then if we add those together, what do we get? Good. So f of negative 2 is just equal to 8. But again, be very careful there. Make sure that negative 2 is in parentheses, because otherwise, if you don't do that, right, it's going to square the 2 and then put the negative on it, and then the negative 4 and positive 4 would cancel. Okay, so we have to square the negative. That becomes a positive. Okay, and then our last one here, we've got f of square root of 5. So I'm going to take the square root of 5, I'm going to square it, and then I'm going to add 4. What's the square root of 5 squared? 5, right? So the square root and the square would cancel each other out. It's going to leave us with 5 plus 4, which would give us what? Perfect. Okay, so f of square root of 5 is equal to 9 now. Any questions on evaluating any of those values now? Okay, now let's look at domain and range. So if you remember back in chapter 1, we talked a little bit about domain of an expression. Okay, now we're talking about domain of a function, but it's going to be the same thing. So in this case, we're looking at all the possible x values that we could substitute into this function. All we really need to look at right now is, do we have any x's in a denominator? Do we have any square roots with an x inside, right? Because that's what's going to give us restrictions on our domain. Well, do we have either of those things in this case? No. So what's our domain going to be for this function then? Negative infinity to positive infinity. Good. All real numbers. So we're going to say our domain in interval notation here is going to be negative infinity to positive infinity. There's no restrictions on what the x value could be for this one. Any questions about how I got the domain this time? right, let's think about the range now. So range is going to refer to the y values. Okay, so domain was talking about x's, range is going to refer to y's. So I want to think about all the possible f of x or y values of this function now. So what do you think the range would be this time? It is going to be from 4 to infinity. Good. So in this case, 4 is the smallest possible value I could get for my y. I'm going to go to infinity. Now, are we going to include 4 or not include 4? It is going to be a bracket on the 4, right? Because 4 is a possible value here. So I'm going to put a bracket. Now, let's kind of reason through how we know it goes from 4 to infinity. What's the smallest value I could get out of x squared here? 0, right? Because even if I put negative values in there, when I square them, they're going to become positive. So 0 is the absolute smallest thing I could get. And then I'm adding 4 to that value. So 0 plus 4 means that 4 is the smallest value I can get out of that function. And there's no way I can get anything smaller than that. And again, if I plug in 0, 0 squared plus 4 is 4. That's going to be included in my range this time. Any questions on how I got the range? Okay, and the last piece here, I'm not going to ask you this on a test, but there are some in the homework that ask for a machine diagram. This is basically just saying if I start with x, I'm plugging into some function machine, and it's going to output an f of x value. And within that machine now, we just need to describe what's happening. Well, it's basically exactly what we said in the top part, right? We're going to square the x, and we're going to add 4. And so this would say square x, add 4, and that would be our function machine, right? So every x I'm inputting in there, I'm going to square it, I'm going to add 4, and that's going to give me my output of f of x. But again, the middle two pieces there are the big ones, right? Those are the types of things I might ask you on a test, right? Evaluating a function at a specific point, and then also finding domain and range of a function. We'll spend a lot more time on domain and range, right? So even if it's not 100% clear yet, right, we'll do a bunch more functions with that. All right, so now we want to find all of these values if the function is 3x squared plus x minus 5. All right, so same thing. We're just going to take that value, we're going to substitute it into our function everywhere that we see an x. So in this case, notice there's multiple x's in that function, so I have to put the -2 in place of all of them. I'm going to get 3 times -2 squared. Again, notice the -2 goes in parentheses, plus -2, and then minus 5. Now, again, if you have a calculator, right, feel free just to put that in the calculator and get a value. I'm going to go ahead and do this by hand, order of operations. Where would we start? What would be our first step? -2, and then what are we going to do to the -2? We have to raise it to the second power, right? So we're going to square the -2. That's going to give us 4. So we'll have 3 times 4 plus -2 minus 5. Okay, what would be our next step in our order of operations? Good, we have to multiply, right? So 3 times 4, that's going to give us 12. All right. We'll have 12 plus negative 2 minus 5. All right, and then if we add and subtract, right, because that's all that's left, we can just read that from left to right. 12 plus negative 2 minus 5 would give us what? Five. Good. So 12 plus negative 2 is 10, minus 5 should give us 5. So f of negative 2 equals 5 this time. Any questions about any of the steps for that one? All right, let's look at the next one now. So same thing, I'm substituting 0 everywhere I see an x. 3 times 0 squared plus 0 minus 5. This one you might be able to easily see what the answer is going to be just based off the fact that we're substituting 0 this time. But again, if you follow your order of operations, what's 0 squared? 0. And what's 3 times 0? Still going to be 0, right? We basically end up with 0 plus 0 minus 5. And what's that going to give us? Just negative 5. Good. And again, I don't need to see all of those steps every time, right? If you just recognize, oh yeah, those 0 terms are going to go away. I'm subtracting 5. That's going to give me negative 5. You can go straight to that answer. All right, let's look at f of 4. Same order of operations here. So what's 4 squared? 16. Good. We have 3 times 16 plus 4 minus 5. Now if we multiply, what's 3 times 16? Good. 48 plus 4 minus 5. And that would give us what? 47. Perfect. Okay. All right, and then our last one here, now we have a fraction. So 3 times 1/2 squared plus 1/2 minus 5. All right, so if we go through order of operations, what's 1/2 squared? 1/4. Good. So we square the numerator, square the denominator. It's going to give us 1/4. Bring everything else down. Now, what's 3 times 1/4? 3/4. Good. 3/4 plus 1/2 minus 5. And now, to be able to add and subtract, what are we going to have to do? We need a common denominator. Good. What is the common denominator going to be this time? 4. So our first fraction, we can just leave as 3/4. What about the 1/2 then? It's going to be 2/4. Good. And then the 5, if we write it with a common denominator of 4, what would that be? 20/4. All right. So now we can combine all of those. So again, we're just going to add and subtract the numerators, keep the common denominator. So we have 3 plus 2 minus 20. What would that give us? Negative 15 in the numerator. And then we have all of that over 4. And so this right here would be f of 1/2. Now, you could also get a decimal for that, right? So this would be negative 3.75. Because if you were to put it all in the calculator, right, it's probably going to give you a decimal. Any questions on any of those now? All right. Example 3. Okay, so this is what we call a piecewise function. Okay, so whenever you see a function like this that has a little brace on it, and you've got multiple pieces of a function defined for different parts of your domain. Notice the first piece is from 0 to 2, and the other piece is everything greater than 2. And so this represents a cell phone plan that costs $39 a month. Plan includes 2 gigabytes of free data and then charges an additional $15 per gigabyte beyond that, right? So for any additional data that's used. The monthly charges are given by the function C of X here, okay, where X is representing the number of gigabytes that are used. All right, so if we want to evaluate our function this time, let's look here at C of 0.5. So the first step when we're evaluating a piecewise function is to figure out first which piece of the piecewise function are we using. Well, in this case, our x value is 0.5. Is that going to be part of the top part of your piecewise function or the bottom? It's the top, right? Because 0.5 is between 0 and 2. That means we're using the top piece. And so what's the value of C of 0.5 going to give us? Just 39, right? There is no x to substitute in for. Everything between 0 and 2 now is just going to give us a value of 39. And if you think about the context, it makes sense, right? Because if I use between 0 and 2 gigabytes of data, I'm charged that flat fee of $39 per month. So I only used half a gig this time, and so I'm only charged $39. Any questions on that first one? All right, let's look at C of 2. So again, first step, figure out which piece of the piecewise function we're using. So we're going to use this time. It's still the top, right? Because this sign here is less than or equal to 2. Our x value is equal to 2, so we're still using the top. So what's the value of C of 2 going to give us? Still 39. Good. Again, in the context, that makes sense because, again, we're not using more than 2 gigabytes of data. We're still charged that flat fee of $39. All right, and then our last one here, we're going to look at C of 4. Again, which piece of the piecewise function are we using? This time we're using the bottom piece, right? Because now our x value is bigger than 2, so we've got to go to the bottom one. So now I'm going to substitute 4 everywhere I see an x using the bottom piece of my piecewise. We have 39 plus 15 times 4 minus 2. And now we just have to follow order of operations. What would I do first? Good. So what's in parentheses? 4 minus 2. So that's going to give us 39 plus 15 times 4 minus 2 is 2. All right. Then what would come next? Good. The multiplication. 15 times 2 should give us 30. So now we have 39 plus 30. And so what's our final answer going to be this time? 69. Good. All right. So now the only other thing I would say on this problem in particular is because it's contextual, right? Let's think about our units. So for each of these values that we just found, what are the units going to be? Dollars, right? So we found a cost based off the number of gigabytes used. And so all of these now, this is $39, $39, and $69. Again, always go back and think about your problem. Make sure that your answers make sense. That last one, we used 4 gigabytes of data. We know we're getting charged $15 per gigabyte over 2 gigs, right? And since we used four, that means we were charged twice that $15. That's $30 in addition to the $39 up front. And so that's why we end up getting charged $69 total to use 4 gigabytes of data. Any questions on any of those now? All right. Net change. Okay, so the net change in the value of a function as the input changes from A to B is given by the formula f of b minus f of a. All right, so basically we're saying on our graph now, let's kind of sketch this out. We have an a value, we have a b value, and then in terms of our y's, let's say we have an f of b and we have an f of a, right? Because those would represent y values. So that means on our graph, we would have a point at a f of a, we would have a point at b f of b, and we're just trying to figure out what is the net change in the y values between those 2 points. Okay, so basically, how far have we gone in terms of y values between a and b now? Now, b is always going to be the greater of your two values. Okay, so if you're talking about going from one point to another, just make sure that your a value is always the smaller value, the b value is always the larger value, right? The f of b and f of a, it doesn't matter. It's just the a and the b themselves that we care about. A is always smaller, b is always larger. All right, so now we're given the function f of x equals x squared. We want to find our net change between 1 and 3. Right, now, the first thing we want to do is identify what's our a value, what's our b value. So what's a going to be for this first one? 1, right? So remember, a is always the smaller of your values, which means that the 3 has to be the b value. And now we're going to look at our net change formula. So that's going to be f of b minus f of a. So when I do that this time, that means I'm taking f of 3 and I'm subtracting f of 1. Now we just need to evaluate each one of those things. So to find f of 3, I'm just going to take that 3, I'm going to substitute it into my function. So that should give us 3 squared minus, and then I'm going to do the same thing for f of 1. I'm going to take the 1, substitute it into my function. It's going to give us 1 squared. Any questions up to that point? All right, now if we simplify this, what would we do first? we have to square both of those numbers, right? So 3 squared in this case give us 9 minus, and then 1 squared is just going to give us 1. And now all we have left is the subtraction. So when we subtract, what should we get? 8. Good. So our net change in that function from 1 to 3 is going to be 8. In other words, the difference in the y values along that interval is going to be 8 now. Any questions on that one? All right, let's look at the second one. What's our a value going to be this time? -2. Let's remember, a is always the smaller value. It means our b value has to be the +2. So now we use our formula. Remember, we start with f of b. So f of 2 minus f of -2. Still using that same function, right? So I'm going to substitute those values into my function. That should give us 2 squared minus, again, make sure the -2 goes in parentheses here, -2 squared. And just like before, we're going to follow that order of operations, square both of your values. What's 2 squared going to give us? +4 minus, and then what's -2 squared? Also 4. And so what's our net change going to be this time? 0, right? So 4 minus 4 is 0. So we actually have a net change of 0 on the interval from -2 to 2. Again, all that tells us is that the difference in the y values between -2 and +2 is nothing, right? And in this case, that makes sense because at both points we get 4 as the y value, so there is no net change between those 2 points. Any questions on that one now? All right, example 5. So now we've got 2x squared plus 3x minus 1. We want to find each of the following here. I'm going to make, sorry, this one right here should have been an a plus h instead of an a plus b. All right, so let's take a look at this first one here. We want to find f of a. So what do you think we're going to do to find f of a? Just plug in a, exactly, right? So just like we would substitute a number into our function, we're going to do the same thing here. We're just substituting a variable instead. So everywhere I see an x, I'm going to replace it with an a. So that's going to give us 2 times a squared plus 3 times a minus 1. Now, in this case, because we're substituting a variable, there are no like terms. There's nothing else I can simplify. That is my final answer. Okay, can't do anything else to simplify that. Any questions on that first one? All right, let's look at f of -a. Same thing, I'm going to substitute -a everywhere that I see an x. So we're going to have 2 times -a squared plus 3 times -a minus 1. Now this time, because we've got those negatives, right, we can actually clean this up a little bit. What's negative a squared going to give us? Okay, good. It becomes a positive a squared. So this is going to be 2a squared. And then what's 3 times negative a? A negative 3a. So this is minus 3a now, and then the minus 1. And again, nothing else I can do to simplify that, no like terms. So that would be our final answer for that one. Questions on the second one? All right, now let's look at f of a plus h. So, same process. I'm still substituting what I've got there in place of every x in my function. So everywhere I see an x now, I'm going to replace it with a plus h. This is what we're going to get. 2 times a plus h squared plus 3 times a plus h minus 1. So again, all I've done there is I took every x and I replaced it with a plus h instead. Any questions on that step? Okay, now we need to simplify that. So let's start with that exponent, right? I've got a plus h squared. What could I do to square that? What would I have to do that? It's FOIL, right? So we're going to have to write this as a plus h times a plus h, and then we can FOIL to actually expand it out. I'm just going to come up here and do that work. So a plus h times a plus h. Now, if we FOIL that, what's that going to give us? Good, right? So a times a is a squared. Our outer terms would be plus AH. The inner terms would also be plus AH. And then the last terms would be plus H squared. Combining like terms in the middle now, we have 2 of those AH terms. So we have A squared plus 2AH plus H squared. Okay, so just the A plus H times A plus H, the A plus H squared is going to give us that. Now I'm going to have 2 times a squared plus 2ah plus h squared plus 3 times a plus h minus 1. All right, what could I do next? Distribute. Good. So I'm going to distribute here first the 2 into this first set of parentheses. It's going to give us 2a squared plus 4ah plus 2h squared. And then we can also distribute the 3 into that other set of parentheses. So that's going to be 3a plus 3h, and then minus 1. All right, so then if we combine like terms, what's that going to give us? Or do we have any like terms? Let me look at that first. Is there anything that we can combine this time? There's not, right? So 2a squared, there's no other a squared terms. Same thing with the ah, no other ah terms. H squared, ah, and then the 1 is by itself. Okay, so that's as far as we can go with that one. That is our answer for f of a plus h. Any questions on finding f of a plus h now? And again, the big thing here is just make sure when you do a plus h squared, we have to do that work up there. It's really easy just to try to distribute that square, right, to the a and the h. Okay, but just remember that's actually FOIL. So you have to FOIL it out, combine like terms. All right, now if we look at this last one, now we're finding f of a plus h minus f of a all over h. And it just tells us here that h cannot be equal to 0 just because we can't have 0 in the denominator, right? So to find this one, I'm going to start with my f of a plus h. Well, I've already calculated that, right? That's what we just found on the last step. So in place of f of a plus h now, I'm going to have 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. So that right there is my f of a plus h. Then we're going to subtract f of a. Well, same thing. I've already found f of a. That was the first thing we found up here at the top. So I'm subtracting 2a squared plus 3a minus 1. Notice I put all of that in parentheses, right? Because I want to make sure that when I subtract, I'm subtracting the entire function that I got for f of a. And then all of that is over h. Any questions about just getting the setup for that one now? All right, now we need to combine like terms. Now keep in mind here, this minus is going to get distributed to every single term in here. So if we start combining like terms, what's going to happen? Okay, so everything in that set of parentheses is going to cancel with something we already have, right? Because if you notice here, we've got a positive 2a squared. I'm subtracting a 2a squared. That's going to cancel out. Also have a positive 3a minus a 3a. That's going to cancel out. And then finally, we have the negative 1 minus a negative 1 becomes addition. That's going to cancel out. Right? And that's right. So then we're just left with 4ah plus 2h squared plus 3h all over h. Now, is there anything we could do with that to simplify this further? Exactly. We have a common factor of h in the numerator that would cancel out the h in the denominator. So what I'm going to do first is I'm going to factor out the h up top. We have h times 4a plus 2h plus 3 all over h. So again, since I have that common factor of h in my numerator, I can factor it out. And now because I have a common factor of h in the numerator and denominator, my h's are going to cancel. And so what's my final answer going to be this time? Exactly. 4a plus 2h plus 3. That's all we're going to have now for f of a plus h minus f of a all over h. Now, just so you're aware, right, the reason that this formula is important for us is if you do go on to take calculus, this is what we call a difference quotient, and we use this in determining a lot of things that we do in calculus. Okay, so it's important to understand how to calculate f of a plus h minus the f of a, all divided by the h, because we need to know how to simplify that expression to be able to do some of the processes that we do in calculus. Any questions at all on any of those problems now? Okay, let's skip example 6, example 7. So now we want to find the domain of each of these functions. All right, so if we take a look at f of x, what's something that we have here that's going to give us a restriction on our domain? Okay, the denominator cannot be 0, right? So what we want to think about here is that entire denominator, x squared minus x, cannot be equal to 0. So whenever you have x's in the denominator, just take the entire denominator and say that it cannot be equal to 0. Now we need to solve that. How am I going to solve x squared minus x can't be equal to 0? Okay, so if we move the x, right, then you'd have x squared is not equal to x, but we really wouldn't be able to do much else. Okay, so Alexander's got it. We're actually going to try to factor this now. We have a common factor of x. We'll have x times x minus 1 can't be equal to 0. Now, once you've factored it, then we can do what? Good. Set each one of those factors not equal to 0. So we'll have x is not equal to 0. X minus 1 is not equal to 0. Well, x is not equal to 0 is already solved. Can't do anything with that. What about the x minus 1 can't be 0? Okay, good. X can't be equal to 1 because we would just add 1 to both sides. And so we get that. Okay, so now we know we have restrictions at 0 and 1. So if I use interval notation to write this, what would my intervals look like? Good. Negative infinity to 0. Then we're going to go from 0 to 1. And then finally from 1 to infinity. Right? Because we want to include every other real number except for 0 and 1 in this case. So we end up breaking this into 3 separate intervals. Be careful. Make sure you have that interval from 0 to 1. That's one that a lot of people leave out a lot. Okay, so just make sure that there's still an infinite number of decimal values between 0 and 1. So we have to have that interval in there. Any questions on that one? Okay, so we're out of time. That's where we'll stop for today. I will come back and do one of these other two tomorrow, but if you want to see both of them, again, the video is posted for section 2.1, and so you can actually see the other one that we don't do tomorrow. Okay, but then we're going to pick up and continue on with 2.2. Again, don't forget that your test is due by midnight tonight if you have not already submitted that. And that's all I got. So have a great afternoon. Let me know if you got any questions, and I will see you all tomorrow.